everyone, this is Jason. We're looking at an example of a rational composite function. And so what we have to do here is we have to put one function into another function, simplify it to get a new composite function. So this one has a lot of work, so just pay attention to what I do and follow along. The work's not as bad as it looks at the start, but there's a lot of simplification. So let's take a look at what we got going on here. So we're doing f of g of x. So that means I'm going to take the g function right here, the g function, I'm going to put it into f. So we're doing f of 2 over x plus 1. Okay, so that means I'm taking everywhere I see x, I'm replacing it with 2 over x plus 1. So that's the first one in the numerator. And here's the second one in the denominator. All right, so that's the easy part. We've done our substitution. Now we've got to simplify by simplifying the numerator and simplifying the denominator, and then simplifying it one last time to get a single fractional rational expression. So first step, we have to do our LCD and get equivalent fractions. Okay, real simple. And this could be different in numerator and denominator for certain problems. Because we're doing a composite, it's going to be the same. LCD for numerator and denominator is going to be x plus 1. So in the numerator, I know that my LCD is x plus 1. I've got two fractions here. One is that one, and then one is the 2, so that's x plus 1 right there. So since this is a whole number, it's real simple. Whatever the whole number is, we're going to multiply it by the LCD. So that's where that comes from, and that one doesn't change because it already is the LCD x plus 1. Okay. In the denominator, same deal. I've got x plus 1. Okay, that's my denominator. Okay, same deal. The 2 doesn't change. Over here, the second fraction, because it's a 1, it's just x plus 1 over x plus 1. And that reduces to 1. Okay, so that's step 1, finding the LCDs, finding the equivalent fractions. Now we have to simplify. Okay, so we're going to simplify. So what I'm going to do here is I'm going to make one fraction for numerator, one fraction for denominator. So I've got x plus 1. I've got 2 plus 2 times x plus 1. That's my numerator. So that all comes from right here. That becomes the numerator over the denominator. Same thing in the bottom. I'm going to do the same thing for the denominator. So over. And this takes a lot of space, so I'm trying to keep as much visible as possible. So in the denominator, same deal. I've got 2 plus x plus 1 divided by x plus 1. Okay, so now this will simplify. In the numerator of the first fraction, in the numerator, we've got 2 plus 2x plus 2. That's applying distributive property to this one. Okay, all over x plus 1. And the bottom, I don't have to do that, so I'm just going to carry that over for this step. I'm trying to show you each step of my thought processes as I'm doing this. Okay, so that's that. Now we're just going to simplify those fractions best we can. So in the numerator of the first fraction, that's going to become 4 plus 2x. And over x plus 1. And the denominator, the numerator of that fraction becomes 3 plus x. All over x plus 1. Okay, so that's that. And so now I have a fraction over a fraction. So to do that, we're going to divide the fractions. I'm going to show it the long step, and I'm going to show you how I just knew what the answer was going to be. So the long step, I'm doing 4 plus 2x over x plus 1 divided by 3 plus x over x plus 1. Remember, the rule is to keep, change, flip. So we're keeping, changing, flipping. These are going to cancel each other out, leaving me with 4 plus 2x all over 3 plus x. And so how did I know just to go to that step? Or how could I know if the denominators of both fractions are the same? They are going to cancel each other out because of this long step. And so that's going to simplify to 4 plus 2x, or 2x plus 4, over 3 plus x, or x plus 3. This depends on how you want to write it and how the answer looks in a multiple choice answer. So I hope this helps you simplify a problem like this. If not, please let me know. I'll try to find you some additional resources for sort of a very difficult